welcome everyone to the Open Data Foundation Office Hour. And with me, Michelle DiPalma, is my partner, Daniel Parks.
Hi, hello.
So,
How are you, Michelle?
are we doing part 2 of Metro DR? Can you refresh everyone's memory about what we're doing today?
Yeah, that's the idea. No, we are going to continue with episode 2 of the Metro DR series that we started last week, where we covered a little bit the architecture of Metro DR and especially some diagrams around Ceph, and the external Ceph that is needed. Just as a very quick reminder, with Metro DR, we are speaking about the synchronous solution that we have that is data loss 0. You lose no data because we are doing really synchronous replication between both sides. So we have no data loss and the RPO is 0.
Awesome.
Before we started, the only thing that I wanted to mention is we got really good feedback last week from the show and from some emails and also on LinkedIn. And they were right about one thing, that in the diagrams that we were showing during the show, there were some IPs that were duplicated between Ceph nodes in both of the sites. And that was just an error of mine, doing copy and paste from one to the other. So just to be clear, you need to have different IPs on each node that is forming the Ceph cluster. I have corrected that with the nice feedback that we got, so it's now fixed on the diagram that we will show in a moment, because the idea today is go a little bit backward and forward between the diagram and the terminal, so we can get a feel of what the Ceph deployment looks like and how we can check the details of the stretch Ceph cluster. That is what we use with Metro DR.
Awesome.
And finally, at the end, we are just going to do the final step that will be adding, or let's say joining the OCP cluster with ODF external to our RHCS, our Ceph external cluster.
That's the easy part, that final step.
Yeah.
The straightforward part. Okay. All right, so are you going to present? Are you?
Yeah.
Okay, thanks.
Let me share my screen. And you can tell me if you see that okay. I can make it a little bit bigger, I think.
Good. Looks good.
Perfect. So the idea, as we mentioned, is a little bit cover the terminal and what the Ceph or the stretch Ceph deployment looks like. And then at the end, actually connect OCP to this external Ceph cluster. Just before we begin going through the terminal, I would just like to show the diagram that we were speaking and we used a lot last week, where we have both of our data sites, and we have 3 nodes on site 1 and 3 other nodes on site 2, and then we have this arbiter node that is really the tiebreaker site that we have. That is the one that is going to maintain the quorum on one side or the other. Now we're going to explain this a little bit through the terminal.
Okay.
So going a little bit into the steps. Deploying Ceph or RHCS, Red Hat Ceph Storage. Before RHCS version 5, that is the one that we are actually running. 5.3 is the latest version, or let's say 5.2, and we're going to get 5.3. With RHCS 4 and the other versions, that going backwards, we were using Ansible. So we used Ceph Ansible was the name of the RPM and of the GitHub project that we were using, and these were Ansible playbooks that we would just run to get Ceph deployed on the different nodes, and it would also help us a little bit with the day 2 operations. With RHCS 5, with the newer version, the one that we're currently running, we now have Cephadm. This is a new bootstrapping and also day 2 tool that we have that is really integrated into Ceph and makes the deployment and also, let's say, adding nodes. If we want to scale horizontally, adding more nodes or actually adding more OSDs, that just to bring back what we spoke about on the first episode. OSD is a relation with the drives, with the disks, the media that we have on our servers. It makes it really, really easy because it's actually integrated as a module inside Ceph. So it makes our lives easier. So going into the deployment, I have SSH into Ceph boss 0, and if we take a look, it's actually this node here inside one. I'm going to use this node as my bootstrap node, so where I'm going to actually start the deployment of the Ceph cluster. And once the Ceph cluster is deployed, it's going to be just as a normal node running his monitor and the manager and the OSD. So it's going to have the functionality of bootstrapping, and then it will just be a normal node as the other ones are.
So quick question. So right now, Ceph is not set up at all, or some parts of it, and you're going to stretch it. Where are we in our life?
Yes. Just for the sake of time, I have everything running and configured. So I'm just going to show how the configuration looks like, but I'm still going to walk you through the different steps. No, because the deployment of Ceph will take like 30 minutes more or less, so we wouldn't be able to make it. No, so I'm just going to show you the actual command that I just ran before. No, for the sake of time. To deploy the cluster, and then we can see the differences with the normal Ceph and the stretch cluster, and we can cover those. But everything is already running, just so we don't spend so much time here. Okay, so Ceph boss 0 is where I have SSH into. One question that we get a lot, Ceph is deployed on RHEL. No? So if I do here a cat to the Red Hat release, you can see that I'm running Red Hat Enterprise Linux version 8.5. So in that sense, Ceph doesn't run, or the external Ceph doesn't run on Core OS. So you need to run it on your standard RHEL operating system. And also the services that we're going to take a look at afterwards are container images. And Podman is the one taking care of running those images, those container images that actually form the Ceph cluster. So going into the deployment, what do we need? We have some prerequisites that are documented now, and we need to fulfill that we make life easier for whoever wants to deploy Ceph. Bring in an Ansible playbook. So we have an Ansible playbook to fulfill all of the prerequisites, like, for example, synchronizing the NTP clock, downloading Podman to all of the nodes because we need it to run the containers, all those kind of things that we need to have ready on our Ceph node clusters. We have a Ceph Ansible playbook for that we can just run. The other thing is, for example, we can check the RPM that we need to download, that is called Cephadm. And you can see here that we need to subscribe this server to the Red Hat CDN or to satellite or wherever we are storing our RPMs, and then just install Cephadm. Once we have Cephadm in place, we have fulfilled the prerequisites with the help of Cephadm Ansible that we have here. We could also do it by hand if we like. We are ready to start the bootstrapping. Regarding Ceph Bootstrap, we can do it like in two different ways. There's a very easy way of starting the Bootstrap where we can deploy a minimal Ceph cluster. This means that we will just run Cephadm and the Bootstrap command without many parameters, and that will give us a minimal deployment on just Ceph boss 0. Now, on one node, it will just start the monitor and the manager, just the minimal resources to be able to then have the UI. So then you could go into the Ceph dashboard and add your nodes or add the rest of the services that you want to configure, or maybe through the CLI. So everything with that monitor and that manager, the Cephadm module is available, and you could do all of that. And then there's another approach, the one that I followed and that we're going to follow today, that is actually using a YAML file. This is a little bit similar to what we will do in OpenShift, Kubernetes, for example, following a little bit kind of a declarative approach. And in this YAML, what I'm going to do is I'm going to configure all of the nodes that I want to be part of the cluster, the services, and also the placement of each service that we spoke last week. That is very important that we place the services on the right place. So let me just show you what this YAML looks like. It's quite easy to write in the sense that we have service type. In this case, these are hosts. So these are going to be the hosts or the servers that are going to be part of our Ceph cluster. We have the IP address, the host name, and also the data center where they belong. No, this is the location. So this is like the physical representation of where our server is located. This is going to affect the crash map. That is really, again, the physical representation. No, so Ceph knows where a node is actually placed, and also all of the OSDs, all of the media or drives that are under this OSD. No? So, for example, if we check here, we have that we want boss 0, boss 1, and boss 2 to be part of data site 1. No? So you can see here that we have boss 0, boss 1, and boss 2, all of them configured with the crash location of data center 1. If we go a little bit further down, we still are with service type host, and we have boss 3, boss 4, and boss 5 that have data center 2. So really, we're just representing what we have here in architectural diagram and what is the actual physical location of each of the servers. So Ceph is aware of the topology. Another important thing that we're configuring in the host service type are labels. These, again, can be quite similar to Kubernetes labels in the sense that they're going to help us place the Ceph services on where we want to place them. No? So just as an example that we have here, no? in Ceph Post 2, I'm setting the labels OSD, MDS, and Rados Gateway. This means that this actual Ceph Post 2 node is going to get deployed the OSDs, the metadata server, and Rados Gateway. No? So we are specifying where we want each service to be placed with labels. Just to add a little bit more of information, the last service type that we have here, that is Ceph Post 6, you can see that it's different from the other nodes, and we're only setting the label mon. And this has an explanation because it's actually Ceph Post 6 is our arbiter site where we have just one monitor. So just to refresh this a little bit, the arbiter site, there's no data going through the arbiter site. No, it just has a monitor that is going to take care of the tiebreaker of keeping quorum on our cluster. But there is no data replication, nothing going into Ceph Post 6. And that's why you can see here that the only label that we are selecting is mon. We then go into the service types for each service that we have in Ceph. We covered them a little bit last week on episode 1, so I'm not going to cover these now, but we have the monitors, MDS, and we are really specifying the placement here, and we are telling it, okay, out of the 5 monitors that you have to deploy, deploy 1 monitor on each host that has the label mon specified, no? As we saw that we are selecting on the other one. So that's really what we are doing here.
Okay, quick. So just to run through them to refresh people. So monitor and manager of the labels, we have monitor, manager, MDS. Sorry, so monitor, MDS, manager, OSD, and then you specify RGW down below. I was just so like complete list of things you have to plan out and where.
Yeah, we can take a look here. No, that we can see it in the boxes. So that's true. We have monitors that we have 5 of them. No, that we covered a little bit that we want to have always quorum and we want to have an odd number. Then we have the manager, that is really the one helping the monitor with the Ceph dashboard and all of the recollecting of metrics, and also the modules like Cephadm, that is a module inside the manager. And the manager works in an active passive mode. That's why you can see that we have like 1 manager on site 1 and 1 manager on site 2. And then we have OSDs that they are fundamental for Ceph to work. No, the OSDs is really the relationship in almost all cases on a one-to-one basis with drives. No, so 1 OSD, 1 hard disk, 1 drive, 1 flash drive, or whatever we want to mention. And then finally, Rados Gateway. No, that RGW is the S3 endpoint that gives us access to object storage. No, using Rados Gateway. So those are the ones that we need to cover and find a place on the different nodes that we have available on our Ceph cluster.
Okay.
The only thing that I wanted to mention of what I'm showing here is OSDs. OSDs is a little bit special, the service, in the sense that because OSDs really relate to hard drives, to disk, to media, you have to be able to select which drives you want to use from each node. Because maybe you don't want to use all of them, you want to do different tiering between the different drives that you have on one node. No? So in that sense, we have the spec part of the YAML where the spec we can configure filtering. No? So we can have, we actually have many options for selecting, using a filter, which drives you want to use as OSDs or use for Ceph. In that sense, you can, for example, use a size. So you could say disks only used for OSDs, disks that are bigger than 2 terabytes. Or we could use the hardware model of the drive, rotational, non-rotational. There are many ways in which you can filter which disks you are using. In this case, and in this example, I'm using the easiest one that you could actually find. Now that is data devices all true, meaning that just go ahead, scan all of the nodes, and use all of the free disks that you have available as OSDs. So it's really the easiest one to have and to deploy. But as I said, if you check in the documentation, we have many options there available. And finally, Rados Gateway, as you mentioned, Michelle, that is really the S3 endpoint. What we're doing is we're selecting placement, again, using a label, and we're just specifying that we want to have a count of 2. So we want to have 2 Rados Gateway endpoints available in our cluster. Let me just clear the screen and show you. So the actual command that we will run. So once we have our spec file finished that I just showed you, we have filled in all of the information, we are confident with our file, we can run the Cephadm bootstrap command. This will actually start deploying the full Ceph cluster with all of the specifications and configuration that we set into that file. Just to go through the command, we are using Cephadm bootstrap. We specify an SSH user. This is part of the prerequisites that we have to fulfill. We need an SSH user that is able to do passwordless SSH, let's say, and it also needs to do or to have sudo privilege to run as root. So Cephadm can really go into each node and do the configuration that it needs to get Ceph running. No? Then we have the monitor IP. This is actually the IP of the server where you're running the Cephadm bootstrap command. So in my case, it's the IP of boss 0. No, that is the node that we are running this command on. Finally, we have apply spec. That is just the file that I showed you a moment ago, no, with all of the information about nodes and services. And finally, we have the registry JSON file that here we set the user and the password that is going to be used to authenticate against Red Hat CDN registry, no? Because we need to download the container images that are actually going to be used for our Ceph services. So here we specify those. So then we will actually run this command. This will take, as I said, no, for a while, depending on the size of your cluster, the amount of nodes, the amount of OSDs that you are configuring. And when it finishes, you would get a URL, no, with the IP and the path, the HTTP path to the Ceph dashboard. You could go into the dashboard and then do configurations as needed. On the other hand, you can also stay with the CLI that we're going to do today, and you could start checking how your cluster has been deployed, if everything is looking okay. So to go a little bit into that, we could, for example, start taking a look at our hosts, no? So the different hosts or nodes that have been configured in our cluster. You're going to see that I'm using the Ceph org command. This is Ceph orchestration. So we use this command. It's very powerful. It has a lot of options. But as I said, when we're adding, removing nodes, adding a new service, removing a new service, even updates, upgrades of Ceph are now taken care by the Ceph org command. It's really Ceph org upgrade, and then the upgrade will start for you. So it's really very well integrated with Ceph and makes our life easier in that sense. going into the output of this command, you can see here that we have our 7 Ceph nodes, the same that we have in the diagram with the IPs, and then the labels. These labels are the ones that we set, if you remember, that we showed in the file just a moment ago, where we are specifying what services we want to run on each node. All of these services are really what we will need to fit now in our architecture, and I'm really following the guidelines that we previously set in this architecture diagram. No? So whatever you see here is really represented using labels. Just in case you, yeah, go ahead.
I was about to ask about that label. You're highlighting admin. Okay, so
yes, that's a good question, because just in case somebody wanted to know, you can specify the admin label to whatever node you want, or to more than one node. And what's going to happen when you specify that label is that the Ceph key, admin key, is going to be deployed on that host, on that node. What this means is that we can run from that node Ceph commands without actually having to exec into the containers, do a podman exec, or maybe a Cephadm shell. No, so you actually can run Ceph commands on the host, because we are copying a key that really the key is used to authenticate against the monitors, against Ceph, and be able to run commands. So if I didn't have in this node, for example, the label, I wouldn't be able to directly run the Ceph org command. No, that is why it's quite nice to have, or to set the admin label, and then you can actually run Ceph commands from the node, no, wherever you need.
So normally, I mean, I know this is just, we're just doing a demo, but under normal circumstances, wouldn't you want the admin label on your Arbiter node next to mine? Because it's going to withstand, like if you have it on BOS 0 and that whole side goes down, you have to do the trouble of resetting everything up on the other side. But okay, so just
that's a very good point. I would actually have it like on site 1, on site 2, and on the Arbiter. No, so then in that sense, you're sure that even if you have a site failure there or whenever, you are going to actually be able to run Ceph commands and take a look at what's going on. It's true that that is not very difficult. You can do just a podman exec and exec into whatever Ceph container, or a Cephadm shell command, and you would also do the same. No, so it's just one step to make your life easier, but it's not very important. But that's a very good point you made. No, maybe you could really have your keys in both of the sides, and on the Arbiter side, just in case, you can still keep running your Ceph commands easily, in case you have an issue on Ceph BOS 0, no, on site 1.
All right, so labels look good, IPs are correct.
Yeah, so then we could move into Ceph, for example, org again, and then ls. And here we will list the services that are running on our Ceph cluster. On episode 1 the other day, we didn't speak about these, and we haven't started speaking about them today. We can just ignore them. I'm just going to mention, like Alert Manager, Grafana, and Prometheus, that this is actually the observability stack that we use for Ceph. Because if somebody has played with Ceph, or maybe with ODF, we get metrics, we get information from the cluster, and all of these graphs that you get are actually using this stack, no, with Grafana, Prometheus, and the node exporter. So we can just forget them about them right now. That's deployed by default, so you can have observability on your cluster, and it's always running. You could also place it wherever you want to place them, no? So the same placement rules apply, but in this case, we're just avoiding them just to make our life easier. So going into the actual core Ceph daemons, we can see here that we have MDS, Manager, Monitors, and Rados Gateway, and also our OSDs available. Here you can see how many of them are running, but we don't go a lot into detail. No? So if we wanted to go a little bit more into detail, we have the Ceph org ps command. And this one is really nice because you can see for each node the services that is running. You know? So let's just do a moment and choose, for example, 1. Oh, and then clear the screen so we can see a little better. So here we have the Ceph services running on BOS 1, and we can see that we have a monitor, we have 2 OSDs, and the other ones are just from the monitoring stack. So important things to take into account here that we can now check. Okay, we have the monitor and the OSD is running. Let's see in our diagram if that's actually what we wanted, and that's correct. No, both one, the monitor and the OSD. No, so let's say that you could check using this way that the placement has worked, or you could just select a service. No, so for example, let's check Rados Gateway. Let's see if the placement is correct, if the service is up and running. So here again, we can see that we have two Rados Gateway instances or endpoints, and one is running on bus 2 and the other one on bus 5. If we check with our diagram, bus 2, that is site 1, and bus 5, that is site 2. So again, we are deploying one Rados Gateway on each site, so we could tolerate the full failure of one site, and we could still keep serving S3 client requests on the other side. That's a little bit the idea of the configuration that we're using with the threads cluster.
Okay, so can we tell from Ceph org that like which side is live, or like so what are they? So the RGW one is load balance. And make sure I'm not getting them confused. Like there are ones that are hot, one's live, one's cold, and there are other ones that are load balanced. So like, could you check the status of that from here, or do you have to check it in another way?
Yeah, we will check it. We can check it just now. You have like the Ceph. Let me just clear again. You have the Ceph -s command that is really important, and is the one that gives you a global view of Ceph. And this Ceph -s, or you could use Ceph status, no? And in this sense, you can see here that you have, well, the first thing to check now is that the health of the cluster is health. Okay, that's always good news. And then you could go into each service, let's say, no? So, for example, you can see here that the monitors, we have 5 of them, and all of them are in quorum. No, that is a good sign. So everything is working with the monitors. With the manager, we already spoke that we are active passive. So you can see that we have on bus 0 the active manager. And just in case we have an issue on the other side, on bus 3, we have the manager running. Okay. Again, with MDSs, you don't get the detail of where each one is running here. We could check it with more commands. And the OSDs, again, 12 up, 12 in. And Rados Gateway, that is the one that we will just check in now. We have 2 hosts and 1 zone. Not 2 hosts, meaning that we have two daemons active, no, and on different hosts. Okay. So in that sense, this gives you a really good, easy view of the state of the cluster. And also, if we have time, I'm not sure if we are going to have time, I was going to simulate a full failure of one site, so we could also see here how you get the warnings. But you could perfectly see what's up and what's down. It will tell you 3 OSDs are down, 1 data center, 1 full data center has gone down. No? So you get all of the information using this Ceph -s command. Is really important when running a Ceph cluster, because it gives you like a good view of what's happening.
Nice. Cool.
And the final one that I wanted to show very quickly regarding the Ceph org device is Ceph org device ls. And with this command, we can list the drives that are available on our nodes. So Cephadm will go into all of the nodes, will scan all of the drives that we have, and will check the ones that it can use and can't use, depending on the filter that we have specified on the spec file, no, that we showed at the beginning. Mm-hmm. From what we have in this output, we can see that on each node, not including that byter, we have 2 drives, SDB and SDC, of 53 gigs each. And the rejected reason is that there are actually already OSDs. No? So the thing is that if you would have an empty drive, you would see available true and no rejected reason. In this case, they are being rejected, but because they have already been used. So this is really regarding how Ceph can scale. If we went ahead and added new drives to the node, straight away they would appear here as available true, and then because they fit in the filter that I have set, they would be automatically added into the cluster, no, with the current configuration that we had, and we would directly have more raw storage available to use in our cluster. So again, making our life a little bit easier. I just wanted to show the list block device. just so we can check that we have SDB and SDC, and that's actually what we have on Ceph Boss 0. SDB is being used as an OSD, and SDC also being used as an OSD. So also nice command, the Ceph ORCH device, to check the status of our drives and if you have drives available and things like that.
Awesome.
Okay, so with this, we covered a little bit what's the Ceph ORCH and the part of the deployment. I wanted to just very briefly talk about the monitors. Let's just get on them on. Okay, so we have 5 monitors, 2 of them on site 1, 2 of them on site 2, and our Arbiter monitor. There is an important thing here. Let me just get the election strategy that I wanted to mention, that we have to set for stretch clusters. Let me clear this so we can see it better. So really, when we're speaking about monitors, as we said last week, we need to have, or they are the ones taking care of the status of the cluster and that everything is correct in the cluster, in the Ceph map of the different OSDs and the different things that we have inside the cluster. So for them, having quorum is the most important thing that they have to take care of. And for that, they use the Paxos algorithm, and there was, let's say, the classic election strategy that is the one that has been being used for many years with Ceph, and that you normally use when you're doing a standard Ceph deployment. But when we go into stretched deployments, we have to select connectivity. Connectivity is really an enhanced election strategy that is based also on pings between the monitors, and let's say that each monitor has scores, and if you respond to more pings and you're stable along the time, your scores are going to go up. So it's really taking care of the quorum and trying to avoid split brain situations that you could get with a classic election strategy. So it's really an enhanced election strategy that we have to configure and we have to set with this command. We will actually run Ceph mon set election strategy connectivity. This is also on the documentation, and this would get us going related to the mons. Okay. If we want to check the mon status and also the configuration, we can use the Ceph mon dump command. Here we have the election strategy number 3. This is not very intuitive, but this is actually the connectivity election strategy that we just mentioned. We have a stretch mode enabled that is set to 1, meaning that we have already gone into stretch mode, running a command that I will also share afterwards, and that our tiebreaker monitor or our Arbiter monitor is Ceph Boss 6. We also specify this in the command, and this is just, again, the one that we have running on this site.
And then
finally, go ahead.
I was going to say, so Ceph Boss 6 can't be the leader?
Yeah, that's the thing that, so because it's the one that has higher latency, if you remember, we were speaking about that the Arbiter can have up to 100 milliseconds. We are trying to avoid for that monitor to be the leader, just to avoid all of that latency and delays that we will get going all the time to that monitor. So that's why you see this. But it just behaves a normal monitor. The only thing that they can't actually be chosen as a leader, but it can be used to form quorum. That is actually his mission.
Okay.
And related to the locations, this is something that we also have to specify, is again given, so Ceph knows the location of each node. So here we are setting, again, for Boss 1, 0, data center 1, 3, 4, data center 2, and for Boss 6, data center 3. It could be any labels that we want to specify that actually mean something to us. But it's just having Ceph know the physical location of each monitor. Okay, so with this, we have also covered monitors. I just wanted to very quickly show you to finish the OSD tree, just so we understand it a little bit, and we can go through this a little bit. So this, when you run the Ceph OSD tree, this is the crash map output, and this is kind of a hierarchical output, no? In the sense that what we have is data center 1, and under data center 1, we have our 3 hosts, no? Boss 0, boss 1, and boss 2. And then under each host, we have our OSDs. With data center 2, exactly the same. So as you can see, this is really like a view or a representation of our physical topology. So what this provides us is a way of being sure or easily for Ceph to identify where it has to store each replica. Because again, when we are working with Ceph, in this case, a stretch mode, we need to configure our replication scheme. For a stretch Ceph is replication 4, no? Is what we are able to configure. This is that when a user writes an object, we're going to store 4 copies of those objects. What we need to be very sure of is that we store 2 copies of that object on site 1, on DC1, and 2 other copies of that object into DC2. No? So that's why this representation of the crash map is really important. This representation gets configured just by the location that we set during the bootstrap command, no, where we have the spec. And if you remember on that spec file, we were specifying which node belonged to DC1 and DC2. So everything gets configured for you and on this crash map from what you configure on that spec file. No? So you don't have to do anything extra, just run the bootstrap command in that sense.
Okay, quick question. Can I see? So in part because it's a demo, everything's nice and symmetrical, right? We've got 3 on one side, 3 on another, same. So what if, do I have to worry about if I'm mixing and matching hardware devices underneath? Like, let's say I'm using old drives on one side and we're migrating, like there are all kinds of reasons why one might do that. Are there anything I have to worry about in terms of replication, or as long as there's enough volume on each side? Like I'm just curious.
Yep.
If there's
that's a good question, and it's important. Let's say that you can work around it, but it will make your life much easier, and it's also what we support and recommend. If you have the same amount of OSDs on all of the nodes that you have, you don't need to have symmetric nodes. That's not the case, and you also don't need to have symmetric OSDs. But it is the recommendation. Why? Because if you don't have the same amount of OSDs on each node, you are going to get OSDs that are actually going to start having more data than the other ones. So you start getting an imbalance between the amount of objects that you have on each one. And that's why you also see here weights. And that would be one way that you could get around it or fix it if you have more OSDs on one node than another. But ideally, with hosts, it's not so important. But with OSDs, you will have, if you can, the same sizes, the same type of drives, and also the same amount of OSDs. If that's impossible, you can get around it using weights and up maps. There's different strategies that you could follow. But to answer your question, ideally, OSDs, yes, it's a good idea to always have them on the same size if possible and the same number. With hosts, you can have an imbalance. In the end, it's not going to matter. Okay, so that's what I wanted to show you just in that case. And just before I forget, what I also wanted to mention is how do we actually implement the replication scheme and we enforce that we get 2 replicas on each site? That is done with a rule, and that we have to write by a rule. And let me show you here. I'm not going to go into details, but just very quickly so it makes sense to you. What we are seeing in this rule that is called the stretch rule, and is the one that we have configured, what we're saying is, okay, out of your 4 copies, each time you do a write, select 2 of those copies, 2 replicas, and store them in DC1 or store them in hosts that belong to DC1. And then the other 2 replicas, go ahead and store them on hosts that are on DC2. So as you can see from this rule, what we're really telling it is how it actually has to behave, no? Saving 2 replicas on one side and 2 replicas on the other.
Okay.
The missing piece for this is, okay, you can say we have a rule, but where do we apply this rule? No? And that's where also Ceph pools come into play that we briefly covered the other day. Really, a pool is just a logical aggregation of objects. No? To make our life easier, we can aggregate objects by use case or by whatever we want to create pools for. Normally, it's related to use cases. By use cases, I mean, for example, we can see here that we have an RBD pool for everything related to RBD. This is block. No? When in ODF, we use the storage class that is for read-write once for block. We're actually adding objects to this pool. You can see here that we have CephFS, that is our shared file system, or Rados Gateway, that is the S3 endpoint. No? So we really segregate by pools to make our life easier and have everything organized. And then what you can do is that you can set a replication scheme and a replication rule to each of these pools. No? So if I do, for example, Ceph, make it easier. Yeah, so here we have a list of our pools that we just mentioned before, and I just wanted to show that we have replicated size 4, meaning that this is replica 4 for all of our pools. So that's why we are getting 4 copies for each write. And then crush rule that we have selected is crush rule 1, that if I just show you again, sorry, not this one, the other command that we're using, ID rule ID 1. No? So that's just to close the circle, that's the relationship. No, you have a pool where you select your replication schema and the rule that you are, the crush rule that you want to implement. And then you're making sure that you're getting 2 copies on each site and that you can tolerate like a full site failure. No, that's a little bit the idea behind it.
So you could potentially decide by pool the level of replication you want, and so based on how important the data is to you, or if it's already being replicated in another way, like in the app or something, you're not going to want 4, you're going to want maybe just 2 or whatever. Okay, all right, that's nice. Yeah. And how you want it replicated across the, okay, perfect.
Yeah, that's right. On a normal Ceph cluster, that's the case, and you can play with that. You can use erasure coding even if you like. With a stretched clusters, at the moment, we're a little bit more strict in the sense that when you actually deploy it, all of the pools that you have, or all of the pools that are using the default role, are going to get automatically configured with that kind of replication. No, afterwards you can go in and add pools with a different replication, but we're a little bit strict with that when using the stretch mode.
Sure. Okay, that makes sense. Cool.
Okay, so going into what will be the next step, that is actually deploying or connecting OCP to our external Ceph cluster using the ODF operator. That will be this step here. No, so what I have is already an OCP cluster deployed that I'm going to show you just in a moment. Let me make this a little bit bigger. It's deployed with OCP 4.11, and what I'm going to do is just install a moment the ODF operator. Data foundation, I think that pops up. Yeah. Again, version 4.11 because we're running OCP 4.11, and let's just install this standard deployment of the ODF operator. So really, what we're going to do here, or what you need to do is we have to understand that because we want to connect OCP to this Ceph cluster, this OCP needs credentials, and it also needs IPs, to where to connect to the monitor. So what we are going to do is that we are going to run a script that gets all that information for us. It gathers all of that information, it creates the needed users in Ceph, and then we would give that script to our ODF operator, and he will be able to connect with all of the data that we provide, because it's really the keys that it needs to have rights to access, read, write to the Ceph cluster.
This is a different Ceph user. This is not whatever got used before. We had a Bootstrap user, I think. This is all okay. Just
Yeah,
curious.
yeah. There actually you get, and I'm going to show you in a moment. You get actual users for everything. So, for example, the CSI RBD provisioner is going to get one user. The Cephfs provisioner is going to get one. So it's quite compartmented for security. Also.
Okay.
So this is the Python script that you actually run. Let me again clear the screen so we can see it better. This Python script is actually provided, and I will show you now in a moment, by the ODF UI. From the dashboard, you can download this script, you upload it to your cluster, and then you run it. What I'm setting here is some information that is needed by this script. So, for example, I am specifying which RBD pool I want to use for this cluster. So in this case, I just showed you in a moment. If not, I can show in a moment, but this is the actual pool that we're using, RBD pool. And I'm also specifying the RDW endpoint that I want to consume. So really what I am doing here is specifying this RDW. So we want to configure, as I showed here, that this OCP cluster connects to this endpoint. And once we have everything in place, we just run this script, and what we're going to get is, actually, let me show you. It's a file, and this file is the one that we have to upload into ODF, into our OCP cluster. And just to answer your question, you can see here that we have like one user with a key, another one RBD. So you have there's quite a lot of different users for different use cases inside. And also very important, also like the monitor IPs, so it knows where to connect.
But it's enough that no one does this manually. Run the script, get the output up.
Yeah, okay. This is still manually. You have to do this. You have to move the script into your Ceph cluster, run the command, get the file, and upload it to your browser. I will show that.
You have to run it on the other side as well, given that it's all local information, local IP. Okay.
Yeah, that's a good point. Yeah, because I'm just going to show it in one because we don't have that much time, how we add one. But as you said, this same process would be on the other side, exactly the same. The only thing that the endpoint for S3 would be replaced, as you just mentioned a moment ago, by the actual endpoint of the Rails gateway from that side. All of the rest of the command is just exactly the same. So at the moment, we don't have a storage system, so nothing is configured in our ODF. Only the operator is running, full deployment. And instead of going with the standard use an existing storage class, I'm going to connect to an external storage platform. It's going to be Ceph storage. So I press next. And from this download script that you have here is where you actually download the script that I was using just a moment ago. So it's actually provided by your ODF operator. So now I will just browse, select the file that we just created. All of the information is there for the cluster, the monitors, all of the keys needed. And then we can just go ahead and create a storage system.
Okay.
So this is going to go ahead using all of those credentials with the help of the Rook operator that is always helping in ODF, and it's going to connect our OCP cluster that we have here to our Rails gateway endpoint, and also to the rest of block and share. So we are going to have everything available just as you would have with an internal Ceph deployment. So once it's go ahead.
Back in the console, we should see our backing store. All the pulls should show up. Everything should look. It looks as if it's local, even though it's external. Does it have?
It looks very similar. It looks very similar. You have some differences, but you still get your. I will say you still get your dashboard. You get all of the information for the metrics. So you're still seeing the IOPS, the throughput. You are getting all of that information. You just have a small differences, as you can see here, external object provider. So there's some differences where the storage classes have almost the same name, but in the end, it's the same experience. You can go here, create your PVs from your storage classes. Nothing changes. So it's the same experience.
Very nice.
And with this, we're more or less ready to go. You can see that the storage system has been detected. And if we go, oh, I'm not logged in. So I was just going to show you the storage classes that you can see here. Now that we have the same storage classes, CephFS, RBD, and RGW. And the only thing that is OCS external storage cluster. So the name just changes a bit, but in the end, it's exactly the same. MCG or Nuba is missing from this list because, as you know, when you deploy ODF, it takes a while until MCG gets going. So that's why we are not seeing it right now.
Okay. Okay. So we have like 10 minutes. And can we fail one side in 10 minutes, or does it, or what is it? You want to do it? Why not? Let's break something.
Yes. Yeah, let's get it go. So in that sense, let me just, because I am using for this lab VMware, so I'm going to use Go BC to actually
just
power off.
What we just saw was data center 1. We saw the left side of your architecture diagram. That's what we were logged into. That's what we saw. Okay.
Yeah. I'm going to power off the nodes, and just so you can see here everything that is going on, that you are going to get a lot of warnings. We want to power off, not on. That's important, off. So this is going to do a straight power off of the nodes, no graceful shutdown or anything, just straight away. It's going to fire the power off. Let's see if it actually is working. Yep. So now in a moment, we will see. Okay. We will see here things start firing off. The first thing that normally gets the notices is the monitors. You can see here straight away. Yep. 2 out of 5 are down. So now the quorum. That's why the arbiter node is very important, because now we have quorum between Ceph post 0, 1, and 6. And now it's also starting to notice that OSDs are missing. As you can see at the moment, it says that 4 OSDs are down, but it will actually, that number will increase. So now all of them are down. We had 6 OSDs. If you remember, we had 2 OSDs per node. We have 3 nodes, so that's why you see 6 OSDs. And then automatically it will tell you, okay, you have a full data center down because all of the OSDs from data center are down. And it's also telling you that you have degraded data in the sense that it's still going to keep working because you have 2 replicas, but you have 50% of your data degraded, that it doesn't have the amount of replicas that it normally needs to have. So it needs to have 4, and now you are left with 2. That's why you have this message here, and you can also see it here. We are missing a stretch mode buckets. This is not 100% intuitive, but it's really telling you that because you have failed the full site, now the OSDs can also do peering and speak between each other on the same side. They don't. It's not required that they actually speak with the other side because we know that is down.
And I know we don't have time for it, but what happens if you bring those nodes back up? What's the rebalancing look like in a
yeah, we can just go ahead and do it, but more or less, okay. What you will get is again moving from, it's called degraded stretch mode. It will move from degraded stretch mode to just normal stretch mode again. So
as all the monitors everything gets back in sync, you'll see. Okay.
Yeah, the only thing that, because we are not writing a lot of data, it's going to very quickly go into sync. But as you said, now what will happen is that the site that is up with those 2 replicas, the OSDs will peer with the new OSDs, not the new OSDs, but the OSDs that are going up again. They will peer in the sense that they're going to speak between each other. They're going to agree who has the latest version of the data, and then they are going to copy the latest version of the data to all of the rest of the OSD that are from the other side. So if you are writing a lot of data and your data center has been down for several days, that it will take a little bit more time for everything to be in sync. If you're not doing a lot, like in our case, we're going to see here, that it's going to go fairly quickly,
So, and I know just talking it through, if we lost data center 2 permanently and we needed to create data center 3 and join that to stretch, basically, are we just repeating the admin commands with the new information? Like we just have to, and then once we bring it online, they peer, and then we just wait because it's going to be a full replication. some time.
Yes,
Okay.
yes, that's absolutely right. So again, we have the Ceph org command and our spec file. So it's really just getting our rel nodes up again with fresh drives. We will just run the Ceph org command and add the nodes, and it will start replicating.
Nice. Great. Okay. Okay. Has it come back yet? I guess it hasn't fully come back yet.
Yes, let me I move from here. I stopped the node. Yeah, but it's up and running again. Let me just show you. You will get health warned, but as you see, all of the OSDs are up. All of the PGs are active and clean. This is because some daemons have crashed. It takes a while until it processes why they have crashed and to get rid of the warn. But in a moment, it would actually go back to health okay. But the big thing that is the OSDs and the data are already all in sync, and all of the placement groups are active and clean, and all of their OSDs are up. So the cluster is healthy again.
Fantastic. Okay, so does that conclude our Metro DR series, or is there what more would we want to show? That was pretty.
Yeah. So the idea is that we will get the help from Annette, and then we are going to actually show the ACM part of it. So we are going to deploy an application, and then we can fail over an application from one side, do a failover and a failback, and see how we have RPO 0. So there's not going to be any data loss between movements. So I think that we're going to end with another episode. We will go through the ACM part and also the application failover and failback, just to be and close the circle.
Okay, perfect. All right, so that's actually at the highest level, watching it
Yep.
fail. Fantastic. Well, thank you so much. That was awesome, and it was really nice to see it fail. I always like to break something, so that was really fun. And until next time, take care.
Yeah. Thank you. Bye, Michelle. Bye.